Time travel has been a hallmark of science fiction for decades, but there is actual scientific theory behind it that proposes it may be more than just fantasy. Einstein's theory of relativity has been followed by decades of examining the possibilities of time travel forward or backward by quantum physicists. If time travel were an option, it would turn everything we think we know about reality, history, and the future of humanity on its head. Albert Einstein's theory of general relativity, published in 1915, was the first to suggest that time is not fixed. Instead, it is woven into the very fabric of space, creating what is now known as space-time. Massive objects like planets and stars warp this fabric, and as a result, time moves slower near strong gravitational fields. This implies that theoretically, a person orbiting a black hole or moving at near light speed would see time differently than those on Earth. Astronauts on the International Space Station actually see time tick slightly slower than people on Earth because of relativity effects, demonstrating that time travel, at least into the future, is possible, though on a microscopic level. But what about moving through time? That's where it gets hairy. Theoretical physicist Kip Thorne has suggested that wormholes, teardrops in space-time, might be tunnels to another place in time. These theoretical constructions, according to Einstein's mathematics, would provide for instant transportation between two remote points and even across centuries. But stabilizing a wormhole would demand a kind of matter with negative energy, something yet unknown. Even assuming time travel were possible, it would be accompanied by paradoxes that contradict the very concept of cause and effect. The most well-known is the grandfather paradox. If you went back in time and stopped your grandfather from meeting your grandmother, then you would never have been born. But if you were not born, then how did you manage to go back in time in the first place? Some postulate that time travel does not permit changes to the past, but rather events follow a path that preserves consistency. Others subscribe to the many worlds hypothesis, wherein every decision creates a new timeline, so you could alter history, but in another reality. New developments in quantum mechanics have put a new layer on the enigma. Researchers have seen particles that appear to influence their own history, a process called retrocausality. Certain physicists think time itself could be more malleable than we know, with quantum entanglement suggesting links between time and space. If we had some way of tapping these effects at the larger scale, it could very well unlock secrets of time manipulation. Though time travel is still in the realm of theory, scientists are continually looking for new means to explore the fabric of time itself. Whether using advanced propulsion technology, wormhole construction, or further studies in quantum mechanics, traveling through time may not be so impossible as it appeared at one time. Should man ever open this door, however, it would create questions of epic proportions on an ethical and philosophical level. Would we be able to recreate history? Stop catastrophes? Or would time refuse interference, leaving fate to remain unaltered? As long as we are seeking firm answers, time travel is still one of science's most thrilling enigmas.